guys, thanks for joining me today. My name is Brendan. I'm going to be your math tutor. We're going to get into some series. We're going to do the nth-term test for divergence. So let's get right into the video. Alright, so let's go ahead and write out what the nth-term test for divergence really is. Let me pull up my draw tool. Alright, so the nth-term test for divergence says that if we have a series of a of n from n is equal to 1 to infinity, then we can take the limit as n approaches infinity of a of n. And if that does not equal 0, then a of n diverges. Okay, so we can go ahead and use this definition, and then we can test it out on a series. So let's go ahead and see what that would look like. So I'm going to take this series as n equals 1 to infinity, and let's just go ahead and take the rational function 4n squared plus 5n plus 3 over, we'll go 6n squared plus 2. Okay, so what we want to do on this is we want to take our a of n piece. So I'll go ahead and specify what is the a of n piece. So the a of n is going to be our function inside of the series. So this is a of n. Okay, so now if we're going to take the limit as n approaches infinity of a of n, that's going to be the limit as n approaches infinity of 4n squared plus 5n plus 3 all over 6n squared plus 2. Okay, so now we have to solve this limit to infinity. And the way that we do that is we're going to go ahead and multiply both the top and bottom of the equation by 1 over n squared. 1 over n squared. Okay, so if we do that, we're going to let's see what we're left with. So we have the limit as n approaches infinity of, so if I distribute my 1 over n squared through, I should end up with 4n squared over n squared, which is just going to be 4, plus, so 5n over n squared, that's going to leave me with 5 over n, and then plus 3 over n squared, divided by, so on the bottom, we're gonna get 6n squared over n squared, so that's just going to be 6, plus, then we have 2 over n squared. Okay, so now I can go ahead and start plugging in my infinity. So if I plug in my infinity, this piece is going to go to 0 because we have 5 over infinity, which our denominator is getting really, really large, which means our expression is getting closer and closer to 0. So the same thing happens with this 3 over n squared. So that goes to 0. And then same thing with this 2 over n squared in the bottom. So then this limit is going to just equal 4 over 6. So our limit of a of n is equal to 4 over 6. But then, so let's go back up to our definition. So if we have the limit of a of n as n approaches infinity of a of n, if it does not equal 0, then a of n diverges. So here we showed that the limit of a of n of our series that we're trying to see if it diverges, we got our limit to be equal to 4 over 6. So by the definition, we know our series our series over here, this one, we know that by definition, this one diverges. Okay, so in this next video, I'm hoping to do one where we can show that the divergence test is inconclusive. And one thing to just remember, that the nth-term test for divergence, it does not tell you if a series converges. We can only use it to show divergence. All right, so I hope to see you guys in the next video.